Welcome to our fourth biology video. Today we're going to be looking at the wonders of water. By the end of class, we should be able to appreciate and describe the importance of water to life on Earth, define polar, covalent, and hydrogen bonds, define intramolecular and intermolecular bonds, be able to identify polar, covalent, and hydrogen bonds within or between water molecules, and be able to identify 6 essential properties of water that result from its polarity. And then we should be able to explain how these properties make it an ideal medium for life on Earth. The first 4 we'll be looking at in the video, and the second 2 we'll be discussing in class. So to begin with, let's look at some quick facts about water. The human body on average is between 50 to 65% water, depending on your body makeup. More muscle, more water. Human blood is approximately 83% water. And if you're thirsty, you're already dehydrated and you've lost about 2% of your body's water. As an athlete, this is a concern because it results in a 20% loss of muscle efficiency. If we look at Earth, 70% of it's covered with water. Sorry, just ignore that. Which equates to almost 1.4 billion cubic kilometers of water. That's a tremendous amount of water, but unfortunately, less than 1% of that is available to be used by living creatures such as us, because most of it's salt water and a large amount of the fresh water is either trapped in glaciers or deep beneath the Earth's surface. To understand how water is so essential to life on Earth, we first have to understand its structure. There's 2 main ways we can represent the structure of water. The first is what we call a ball and stick model. Very simple picture of water, but it allows us to concentrate on the intramolecular bonds. So what is an intramolecular bond? Intra means within. So an intramolecular bond is a bond that occurs within a molecule. So in this case, the bond within a single molecule. We will use the prefixes intra and inter a lot throughout biology, so you need to get used to the fact that intra means within. Okay, so if we were to draw a ball and stick model of water, you've probably seen this before. We have oxygen, and off of it 2 little hydrogen atoms at approximately the angles I've shown here. Those angles are determined by the spatial arrangement of the actual atoms and their electrons. This represents the intramolecular bond. And in this case, it's a covalent bond. Which, if you recall from our previous lessons, is a bond where electrons are shared between 2 nonmetals, or more than 2 between nonmetals, which in this case hydrogen is acting like a nonmetal. Now what's really unique or important about water here is that the electrons aren't shared evenly. So electron not shared evenly. It actually is slightly more attracted to oxygen molecule. It spends more time at the oxygen, so we're just going to draw an arrow here indicating that the electrons actually like to spend more time with the oxygen. They still spend some time with the hydrogen, but not as much. This makes the oxygen what we call slightly negative. This little baby delta symbol means partially or slightly negative. It doesn't have a full negative charge like an ion would. It hasn't stolen an electron completely. It's just sharing the electron and taking it more of the time. This means the hydrogen has a slightly positive charge. Again, not like a full-on ion where it's fully given away its electron, just it has the electron less of the time, so it's slightly positive. This is what we call a polar molecule. Has slight charge differences at opposite poles. Sorry, I just somehow grabbed that with my hand. Now we gotta go back to the pen. Opposite ends are poles. Another way to represent water is to draw what we call a space filling model. Now, the benefit of the space filling model is it's more for looking at intermolecular bonds. Okay. So intermolecular. Now the prefix inter means between. If you think about an interstate highway, it goes between many states. If you go on an international flight, you're going between nations. An intermolecular bond is between two or more molecules. So in this case, the space filling model is more like what you think of as a Mickey Mouse model of water, or what I like to think more like the teddy bear model of water. So if we were to draw oxygen, then off of it, attached to it, are the two hydrogen molecules, still covalent. And they're still going to have their slightly positive charge on the hydrogen and slightly negative charge on the oxygen because the electron's spending more time with the oxygen. But if you get a group of water molecules together like this, they're actually going to interact with each other. I draw my teddy bear. The slightly positive ends of the hydrogen end are going to be attracted to the slightly negative ends of the oxygen. And we're going to get what's called hydrogen bonding. We draw the hydrogen bonds with dashed lines. Okay. So these are what we call the intermolecular bonds, the ones between various water molecules. And in this case, they're called hydrogen bonds. And they're slightly weaker. They're drawn with the dashed line because they're not as strong as an ionic or a covalent bond, but they are still strong enough to have a significant impact on how water behaves. And just because we've seen hydrogen bonds before, you have to think way back to biology 11 and DNA structure. They don't just form between waters. There is a more general description of hydrogen bonds. So it's when a slightly positive hydrogen from a covalent molecule associates with a slightly negative atom from another covalent molecule. That's the basic structure of water. It is covalently bonded within water, but because the electrons aren't evenly shared, you get a slightly negative oxygen end and a slightly positive hydrogen end. And these slightly negative and positive ends will then interact with other water molecules to form hydrogen bonds, which help determine how water behaves. We're going to just call that right there. If you have any questions about this, we can discuss it in class. If you were away and you're needing to see the whole video, wait 30 seconds and I'll pick up and finish the rest.